All right, this is day 48. Yeah, let's get it. Let's get it. All right, in this problem, a tree is an undirected graph that is connected and has no cycles. You are given a graph that started as a tree with n nodes labeled from 1 to n, with one additional edge added. The added edge has two different vertices chosen from 1 to n, and was not an edge that already existed. The graph is represented as an array of edges of length n, where edges I is equals ai bi indicates that there is an edge between nodes ai and bi in the graph. Return an edge that can be removed so that the resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the input. If there are multiple, return the answer that occurs last in the input. Okay. I mean, I can definitely. Okay, let's check this input. Copy image. So we have a graph like this. We need to remove one edge from here so that it becomes a tree. A tree is typically a graph with just two children at most. That's what the tree definition here looks like, I believe, or no? No, it can have multiple different children, right? More than two. Okay, so here simply if we remove this edge, it becomes a tree, right? Or if we remove any of these edges, it becomes a tree, right? Okay, 2 3, which if there are multiple answers, return the answer that occurs last in the input. Okay, is n given? No, n is not. You're given n nodes 1 to n, labeled from 1 to n with okay. Where edges of I is equals ai bi. Okay, n is not given, so we have to figure out what n is. I mean, yeah, I can create a map. Yeah, a map would be fine, right? And what do we store in that map? I mean, what should we store? I mean, I can create an adjacency list. So 1 has neighbors of 2 and 3. 2 has neighbors of 1 and 3. 3 has neighbors of 1 and 2. Right? In degree doesn't matter because this is an undirected graph. So, okay. Okay, this is a crazy question, man. That occurs last in the input. Oh. What? Okay, one thing to notice here is return an edge that can be removed so that the resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the input. Okay, so 1 2 1 3 2 3. It looks like kind of an union find question, right? Yeah. So input is this, right? So 1 and 2, 1 and 3, right? So 1 2 3 can be in one input, and 2 3. This is a good question. Have I done this before? I have. A long time ago, 3 years ago. Okay, how do I know the root? I mean, root can be anything, right? Hmm. Okay. Okay. If okay. Yeah. Hmm. Hmm. Okay, since this is an undirected graph. Now, okay. Let's see. I see an edge 1 to 2. Okay. Now there is a one connected component 1 and 2. Now I see an edge 1 and 3. Now 1 is in this component already, so I'll add 3 here, right? Because it is an undirected graph and we don't care. Now 2 and 3 both are here. Then we cannot add it. We remove this and store it in to return that, right? I think that is the way to go. Yeah, might be. Let's try. So we need a set of integers. A set of integers. Let's call it cc equals new hash set. We don't need that. For int e in edges if cc dot contains e1 and cc dot contains e2. Oh, sorry, e0 and e. What the fuck? e0 and e1, right? Okay, e0 and e1. Then we don't need this. Else if boolean contains a equals this, has a, has b, has a and has b, then answer is e. Else if has a and doesn't have b, then cc dot add e1, right? Else if doesn't have a but has b, then cc dot add e of 0. Else cc dot add e0, cc dot add e1. Okay, seems to work, but let's see. Okay, wrong. Oh, okay. Expected 410, but output was 68. 410, 4 is already here, 10 is one. Yes, yeah, expected is 410. Why was this 68? Wait a second. If it has a and has b, continue, right? No. Why is answer 6, 8, bitch? I mean, yeah, 4 is there. 10 is also here. I mean, this can be simply reduced if doesn't has a, right? cc dot add e0 if doesn't has b why is 6 8. So I added 9 10 5 8 2 6 1 5 3 8 4 9 8 10 4 10 4 is already here. What? Am I a fucking idiot? Oh, wait, what? 1 second. Yeah. The graph is represented as an array edges of length n where this if there are multiple answers, return the answer that occurs last in the input. That's what I am doing, right? 6 8 appears last in the input. That appears last in the input. What? 6 8 is the last redundant thing here. I'm correct. Yeah. 4 10. Yep. Why is expected 4 10? Let's see the solution. I'm done with this question. Seems like a union find thing. But I need to understand the logic here. Why union find works. N equals edges dot size uf n plus. Oh shit. If root 1 equals root 2, then return true. Oh. What? Correct. Yeah, makes sense. Hey bro, how are you? Yeah, I'm good, brother. How are you, brother? So we need to have union find here. Okay, is there an easier option? Let's see this guy. A valid tree is an undirected graph which has exactly n minus 1 edges to connect n vertices in the tree. Since the given tree has a redundant edge, so there is n edges in the given input. Oh, number of vertices n equals length of edges. So this was the one thing that I missed. What? There is a data structure called union find or disjoint set which has two basic operations, uf.find and union. Okay, yeah, understand that. Then we iterate edge uv in edges. If u and v is already connected in the uf, then we return that redundant edge. Yeah. Yeah, he wrote union find for every language, man. Is there an easier way? Fucking what the fuck? Damn, man. God damn. Okay, so we need to see union find. Let's see from our notes. DSA, trees and graphs. Is there a union find here? Union find. Can I search in this? Yep. Union. No, there is no union find. Okay, let's see. So union find, as far as I remember, is keeping one as root, right? Yeah, let's see from here. So we have a parent size. Okay, union find parent equals. Okay, we create an array of size n, number of vertices. Then we set the root to itself and size of that set to also 1, right? Good luck with the solution. Sadly, I don't understand English enough to watch the stream. No worries, man, no worries. Yeah, I'll be looking for the solution, but yeah, thank you for hanging around in the chat. Nice. Okay, so we set the root of that vertex to itself and size of that set to 1. Then find is basically until we find a vertex with which has its own root, right? Then we keep on repeating. Then union is we basically set the root of one set to another, to the root of another set, right? And we usually do that to the smaller set guy, right? So if root is equal, then return false. Otherwise, if the size of this guy is greater, then size increases and parent of PV is equals PU, correct? Else. Yeah. Now here path compression is also possible, correct? Yep. Here we are doing that. Okay. Let's try to write this in Java. Now. Okay. Class union find. We have int root and n. Now, public union find, we pass in the length. This dot n equals n, root equals new int, right? Now there are two methods here. Public int find int v, and public void unify or union. Let's call it union. Root 1 and root 2. Now in find is very simple. If, also we need to do some things here. For int I equals 0, okay, find if v is not equals root of v. Shit. V, then, or we can do it this way. If v is root of v, then return v, else root else return, find root of v and we change it here, right? And then we also return the same value. Yeah, this is path compression, and in union we use the method we wrote above, right? Okay, instead of this we can do v1 and v2. Now int r1 equals find v1, int r2 find v2. If r1 equals r2, then return true belong to same set. Okay, boolean. Otherwise, if size of r1 is greater than size of r2, then size of r1 plus equals size of r2, and root of r2 equals r1. Else we do the opposite, size of r2 plus equals size of r1, root of r1 equals r2, right? And then we return false, right? Now in here we simply need to so n is edges dot length, right? Yeah, then we need this data structure union find uf equals new union find of size n. Now here for int e in edges, if uf dot unify e0 e1, then return e, right? Union it is. Is he creating with n+1? No. Oh, yeah. Because they start at 1, man. I mean, I could have simply, instead of doing this, if I just do n+1 here, it would work, right? Yeah. So today we learned union find, or we did a revision on that, so that is good. A new data structure under the belt. Let's also pick up one from Leetcode. Yeah, we'll do this very quickly. Container with most water trapping rainwater. Fuck this question, man. I hate this question. I hate trapping rainwater. I never got this. I mean, I never got the logic. So let's do sliding window. Oh, let's do something from union find, man. Or is it just this? You know what? I'll do this trapping rainwater tomorrow with the daily challenge also. So yeah, this was the stream for today. That will be it. I mean, yeah, we learned a new DS, so it's good. I'll be back tomorrow with another set of questions. Till then, GG's.